Welcome back. Today we're going to talk about the next part of conics, and that's hyperbolas. A hyperbola is the set of all points x, y in a plane, the difference of whose distances from two fixed points, foci, is a positive constant. And so what we're looking at here is we have two different pictures that we can sketch. And we'll just start by sketching the first one. If I draw in my axes, and a hyperbola is going to look something like this. And there's going to be some asymptotes in this graph, and so we're just going to start by generally putting in what our hyperbola looks like. These hyperbola have foci here, okay? And so my focus is once again going to be inside the bowl, and it's going to be represented by that C number again. And so in this case, when I've got my two foci and my hyperbola is going this way, the coordinates are going to be negative c, 0, and c, 0. And there are still these vertices. So this is a foci, or a focus. And this is also a focus. Together they are foci. And these are my two vertices right here. So these are my vertices. And so my vertices have that A coordinate, and my foci have the C coordinate. And then there's another coordinate out here, which we'll talk about in a little bit. That's going to be the B, and it's some distance here, and it's going to be related to our asymptotes, but we'll talk about that, like I said, in just a second. And so our asymptotes of these graphs kind of look like this. And so these hyperbolas never get there, but they're going to guide where our graph goes. And so the important coordinates here are, once again, A, B, and C. A having to do with the vertex, B having to do with this point out toward the outside on the axis, which I'm going to tell you about in just a minute, and then C being the focus. An important note, the transverse axis is the one that goes through the two graphs. So in this case, the x-axis is the transverse axis. If I draw my other picture here, it's going to be going the other way. And my hyperbola is going to look something like this. And so when I start labeling my points, once again, I've got these vertices, and this is going to be at 0, A, 0, negative A, and those are my vertices. I'm going to have a focus in here that's going to be 0, negative C. I'm going to have a focus in here that's 0, C. And I'm going to have that B coordinate out here. And because it switches, you're going to notice that all my coordinates switch. Well, that's not anything new to us. When it rotates around, my A and my B are going to switch, but their job is the same. A is still the vertex, C is still the focus, B is still that point on the outside. And my asymptotes go like this. Okay, and then my transverse axis is not going to be there anymore. My transverse axis is the one that goes through them. So in this case, this is my transverse axis. And that's going to be important when we're talking about what the equations are. And so if the transverse axis is going side to side through the two of them, so it's a horizontal transverse axis, my equation is going to be x squared over a squared minus y squared over b squared equals 1. This formula looks similar, but notice that I've got my subtraction sign now. In my second one, it's going to be y squared over a squared minus x squared over b squared equals 1. So notice, my transverse axis is horizontal, x comes first. My transverse axis is vertical, my y comes first. And so that's exactly what we're looking at when we're looking at these two things. Now, just like when we did ellipses, A, B, and C relate in a certain way. In this case, b squared is equal to c squared minus a squared. And so that's how my A, B, and C all relate, those distances between all of my given points. Let's do an example. Finding a standard equation of a hyperbola, I'm going to leave my equations here along with my A, B, and C. Find the standard form of the equation of the hyperbola with a foci at negative 3, 0, with foci at negative 3, 0, and 3, 0, and vertices at negative 2, 0, and 2, 0. Let me just do a sketch because I know that my focuses, my foci, have to be inside the bowl. And so here's one of them, and this is 3, 0. And this one's going to be this way, so that's going to be negative 3, 0. And so that means my vertices being at negative 2 and 2, it's got to look like this. And so we're going to notice my transverse axis is horizontal. And so that means I'm going to use my equation that has to do with my x first. So x squared over a squared minus y squared over b squared equals 1. Well, now all I need is my a and my b. Well, I remember that my focus, that's my c. So c is 3. My vertices have to do with a. So really I'm just looking for b. Well, if I look at my relationship up here, I know that b squared equals c squared minus a squared. And so b squared equals 9 minus 4. So that's equal to 5. So therefore b is equal to the square root of 5. And I can use that to substitute in to my equation. So x squared over 4 minus y squared over square root of 5 squared equals 1. So x squared over 4 minus y squared over 5 equals 1. That's my equation for this hyperbola. Okay, that's all there is to it. Using those different letters and numbers to figure out what's going on with my equation. Next part, those asymptotes. The asymptotes, like I showed you, have to do with my letters once again. And so what I'm going to do is I'm going to show you exactly where those come from. Let's say I've got a hyperbola here, and we know that my transverse axis is horizontal, and these are my a coordinates because they're the vertices. This is negative a comma 0. And then I had this random b up here, seemingly random. So this was 0b, and this was 0 negative b. And the thing that I want to show you is my vertices and my b work together like this. If I drew a rectangle through those points, okay, this one's got to go through there. Struggling. But that goes through all of my both of my b's and both of my a's. My asymptotes go through the corners of that box. So that means that my asymptotes have an equation that's based on an a and b. So if the transverse axis is horizontal, asymptotes equal this. Y equals b over a times x, and y equals negative b over a times x. So horizontal transverse axis. In the same way, if I had my other diagram would look something like this. So my transverse axes would look this way. So this would all be based on the same principle. So this over here is going to be 0 comma a. This is going to be 0 comma negative a. I've got my b, 0, and my negative b, 0 here. Once again, this box that I can draw is going to encompass my asymptotes here. I drew them as lines. Really, they should be dotted like this. And for a vertical transverse axis, like this one here, see it goes vertical. My asymptotes equal y is a over b times x, and y equals negative a over b times x. Okay? Now that's all there is to it. We just use the same principles to find my a and my b and my x so that I can figure out where my asymptotes go and things like that. All right, so let's sketch a hyperbola. I've got this equation here. I know that it needs to equal 1. Okay? It doesn't equal 1. But notice, my x comes first. So we know that it's a horizontal transverse axis. So I know that it's going to have this as its transverse axis. I got to get it equal to 1 first. So I'm going to divide by 16 on both sides. So I've got 4x squared over 16 minus y squared over 16 equals 1. I simplify this. X squared over 4 minus y squared over 16 equals 1. Well, I know that if I've got a horizontal transverse axis, it's x squared over a squared minus y squared over b squared equals 1. And so if a squared is 4, that means a is equal to 2 and b is equal to 4. So what do I need to sketch? Well, to sketch, I need to put in my a's and my b's. So if a is 2, then that means my foci are at 0, 2 and 0, 2, 0, because I'm going to have a horizontal transverse axis, and negative 2, 0. So I'm going to put those in. They're both right there. And so as I've got these as my vertices, it's going to look like this. And if b is 4, I know I'm going to go up 4 and down 4. And these are going to give me my b's. And if I connect my dots to make my rectangle, I can draw in my asymptotes right there. And that's what they're going to look like. So I'm going to have my A and my B, and that's going to give me everything I need to make my graph. So in the next example, we're going to find the equation of a hyperbola. And we've given the standard, we're given, find the standard form of the equation of the hyperbola that has vertices at 0, negative 3, and 0, 3, and the asymptotes are as given. So let's do a little sketch here and just see what we would be dealing with. So if I've got vertices here and here, notice I'm going to have hello, a vertical axis. Which means my equation that I'm going to be working with is y squared over a squared minus x squared over b squared equals 1. Now I just need to find my a and my b. Well, using my information up here, I know that if these are my vertices, then my a equals 3. And if I also use this fact here, and the fact that it's a vertical transverse axis, I know that my asymptotes are y equals a over b times x. Well, that means that I've got y equals, and if a is 3, 3 over b times x, then that means that a over b is equal to this right here. So therefore, 3 over b equals 2, and so b is equal to 3 over 2, which means that my equation is going to use a and b in here. So y squared over 9 minus x squared over 3 halves squared would be 9 over 4 equals 1. So I just use all the pieces of information. I use what my asymptote equation equals, this a over b here. I use what my vertices were at to find a, and that's how I found my equation. All right, thanks for watching, guys, and we'll see you next time.